In this episode, we'll take a first look at statistics by looking at the statistics basics session. So, statistics can be used to describe a population. Some of the ways in which you can do that is, first of all, using a range. Now, the range is the difference between the highest and the lowest value in a set of data. We can also use something called the mode. Now, the mode is the most common value in a set of data, and it's possible for there to be one mode or no mode. We've also got the median. Now, the median is the middle value when the values are ordered in size from smallest to largest or from largest to smallest. And if there are two numbers that are in the middle of your set of data, then the median is the average of those two numbers. You work that out by adding those two numbers together and dividing them by 2. And lastly, we've got the mean. Now, the mean is the sum of all of the values in your data divided by how many values there are. So if we have 5 values in our data, we'd add up those 5 values and divide it by 5, and that would give us the mean. So if we've got a list of numbers, 1, 4, 6, 7, 9, 11, and 11. If we want to find out the mean, we add them together. So 1 plus 5 plus 6 plus 7 plus 9 plus 11 plus 11 will give us 49. And if we count out the number of values, there are 7 values. So to work out the mean, we take 49 and divide it by 7, which will give us a mean of 7. Now here's another list of numbers. See if you can get this one. We've got 5, 5, 5, 7, 10, 12, 14, and 14. And if you want to find out the mode of that set of data, remember you're looking for the most common value. Now there are 3 5s and there are 2 14s, and there's 1 of every other number. So the most common value, or the mode, is 5. Now another way basic way to sort of analyze some data is using quartiles. So the lower quartile, median, and upper quartile are the values at 25%, 50%, and 75% through a data set. So the lower quartile is at 25% through the data, the median is at 50% through the data, and the upper quartile is at 75% through the data. Now, each of those can be written as Q1, Q2, and Q3, and that separates a set of data into quartiles, each quartile being the range of each section. Now, we've also got something called the interquartile range. Now, the interquartile range is the value at Q3, so 75% of the way through the data set, subtract the value at Q1, 25% of the way through the data set. So it's the difference between those two numbers, and we can also say it's the difference between the upper and lower quartile. And it's basically what that is, it's a measure of spread, similar to the range, but it's less affected by outliers that will have a big influence on the range. Now, outliers are data values that don't fit in the same pattern as the rest of the data set. And what that means is if you've got a result that's way off compared to what you'd expect or what the other set of data is, then that is what we call an outlier. So here's a question to think about. The smallest value in a set of the smallest value in a set of numbers is 4. The range is 18. What is the largest value in the set? So if we've got the lowest value as 4, the range is 18. Remember, to work out the range, we take the largest number in a data set and take away the smallest number. So what we can do is we can find out what that largest number is. We can take the smallest number, 4, and we can add 18 to it, and that will give us the answer. The largest number is 22. If you think about it, if you've got the lowest value of 4 and the highest value of 22, the range of those, the difference between them, is 18. So here's a list of some ages of some people in a classroom. So we've got 8, 8, 9, 8, 63, 8, 9, 9, 8, 9, 9, 8. Now from that data, you probably noticed that 1 sticks out compared to the rest of them. And the question I want you to think about is which of those pieces of data is the outlier? Well, everyone is aged 8 or 9, apart from one person who is aged 63. So that will be the outlier. And I think we can probably assume that that's the teacher if it's in a classroom setting. So here's another list of numbers for you. 5, 5, 5, 7, 10, 12, 14, 14. Now if we want to find the mean of those numbers, we add them all up, first of all. So 5 plus 5 plus 5 plus 7 plus 10 plus 12 plus 14 plus 14 will give us 72. And if we count up how many values there are 8 values in this data set. So to work out the mean, we take 72 and we divide it by 8, which will give us 9. Now to recap, which of the following is more affected by outliers? Is it the range or the interquartile range? So which is more affected by outliers, the range or the interquartile range? Well, if you remember, the interquartile range only takes the range between Q1 and Q3, that's at 25% through the data and 75% through the data. And the range takes the full difference between the smallest value and the lowest value, so that one will be affected by outliers.